Okay, welcome back, students. Let's go over 8.6. Okay, parametric equations, graphs, and applications. Okay, a parametric equation of a plane curve. A plane curve is a set of points x, y, such that x equals f of t and y equals g of t, where f and g are defined for some interval. Okay, x equals f of t and y equals g of t are parametric equations with parameter t. So these are two equations for x and y that are dependent upon a third parameter. And usually that t stands for time, okay? So how is x moving in time and how is y moving in time? And so they're defined in terms of t. Okay, there are infinitely many parametric equations for a given curve, y equals f of x. Give two parametric representations for the equation of the following parabola. Y equals x minus 3 squared equals 1. Well, one of the easiest parametrizations is just to let x equals t. And then that allows me to be y equals t minus 3 squared minus 1. Okay? And so I can say, well, we'll just replace t with x. And y. So x is t and y is equal to t minus 3 squared minus 1. Okay, another interesting thing, we see have this kind of like this function inside a function here. We have x minus 3 and then squared. So we could actually let t equal x minus 3. So that would mean that x is equal to t plus 3. And y would be equal to t squared minus 1. So there are, right here, are two different parametrizations, okay, where one we have x is equal to t, and then y is equal to t minus 3 squared minus 1, or we could let x equal t plus 3. If we plugged t plus 3 in for x, you would see that the 3's would cancel, and I would get that t squared. So that's kind of nice. Okay, but starting with the t equals x minus 3, with what I want to replace t with, kind of helps us to derive that. Okay, find a rectangular equation for the plane curve. So now we're going to kind of go backwards. We're going to say, okay, well, what's the xy equation? Okay, given these two parametric equations. So what I want to do is I want to solve one of the equations for t. The easiest one to solve for, because it's not being squared, is this equation for y, t minus 2. So I'm going to add 2 to both sides. And I'm going to say t is equal to y plus 2. And then what I'm going to do is I'm going to take that y plus 2 and I'm going to sub it in to the other equation here. And so I get x is equal to y plus 2 squared minus 1. This is going to give me the equation of a parabola. And so I could multiply that out if I want. I would get x is equal to y squared plus 4y plus 4 minus 1. Okay, that actually combines into y squared plus 4y plus 3. Okay, I could then, well, I mean, that's the equation right there. If I wanted to find some zeros of this, I could actually factor this and set it equal to 0. And if I factored it and set it equal to 0, I would get y plus 3 times y plus 1 is equal to 0. And so I know that y would have to be, when x is 0, y would have to be -3 and y would have to be -1. Okay, when x is 0. So I would get the points 0, -1, and 0, oops, 0, -3, oops, 0, -3. Okay, and then my vertex would be in between these, as you'll see. Okay, because again, the x is going to be 0. The y is going to be at -1. So right here. And then -2, -3. The y is at -3. Well, what happens at -2? Well, at -2, okay, whoops, when y is -2, I should say. Okay, we plug this in, and I get 3. No, I don't. I get -2. Is that right? So yeah, because I get -8 and 4, which is -4 plus 3, which is -1. So I get -1, -2, which is right here. So we do get this parabola that goes here. Okay, like so. And that's that's the graph of that equation. Okay, just for your information. Okay, so this is a parabola. Okay, what about b here? Y equals 4 cosine t, y equals 2 sine t. Now I need to figure out a way to get rid of that t. Well, I do know a way. I do know that that if I solve for cosine t and sine t, I have this Pythagorean identity. Cosine squared t plus sine squared t is equal to 1. I know that as a Pythagorean identity. So if I were to solve for cosine t in terms of x, I would just divide by 4 here. And cosine t is equal to x over 4. So this is x over 4 squared. Do the same thing with sine. Y over 2 squared is equal to 1. So this is x squared over 16 plus y squared over 4 is equal to 1. And that is the equation of an ellipse. Okay, this is an ellipse. What does the graph of that look like? Major axis is going to be plus and minus 4. Center at 0, 0. Okay, so center at 0, 0. Major axis along the x-axis, and that's going to be 4. So I'm going to get vertices at 0. Oh, sorry, -4, 0. -4, 0, and 4, 0. And then if I take the square root of the y, what's under the y value, that's 2. And so I'll get on the y-axis, I'll get -2 and +2. So if I were to graph this, I get 1, 2, 3, 4, 4, 5, 1, 2, 1, 2. Center at 0, 0, major axis at 4, and -4, minor axis up 2, and oops, kind of sloppy. Try that again. Okay, but we do get an ellipse. Okay, so this is an ellipse. Okay. Projectile motion. The flight of an object can be modeled by the parametric equations. X equals v naught cosine theta t, and y equals -16 t squared plus v naught sine theta t plus h naught. Okay, that h naught is 8 is the height at time 0. The v naught is the velocity at time 0. Okay, or when t is equal to 0. So v naught we'll put in here. Sorry, it says x is the horizontal position, y is the vertical position. The theta is the angle of the launch with the horizontal, and t is the time in seconds. V naught is the initial velocity. Okay, at t equals 0, or time is equal to 0. And then h naught is the initial height at t equals 0. Okay, so we need to answer some questions here. How far does the ball travel? How high was the ball? Oh, sorry, I need to read the question. A soccer goalie kicks a soccer ball from a height of 2 feet with initial velocity 26 feet per second and an angle of 45 degrees. How far does the ball travel? How high was the ball kicked? And what was the flight time of the ball? Okay, so we need to look at all of these. So at h naught, okay, h naught is 2 feet. Let's just look at that for a second. H naught is 2 feet. Okay, that's the height at which it was initially kicked. The velocity, okay, the initial velocity, that's v naught, is 26 feet per second. So v naught is 26 feet per second. Okay, and the angle, theta is 45 degrees. Okay, so that's helpful. Okay, so what does this tell us? Okay, well, this tells us, plugging this into the two parametric equations above, we know that x is going to be equal to v naught times the cosine of theta t. Okay, well, what was v naught? V naught was 26, and then we have the cosine of 45 degrees times t. Okay, cosine of 45 is radical 2/2. That's times t. This is going to be 13 radical 2t. Radical 2t. Okay, and that gives me x equals 13 radical 2t. Okay, so that's one parametric equation that I have. Okay, now let's get the other parametric equation. That's negative 16t squared plus v naught, I guess I'll write it out, v naught sine t, sine theta times t plus h naught. Okay, so this is y equals negative 16t squared plus v naught is 26 sine theta, which is 45 degrees, times t plus h naught, which is 2. So y is equal to negative 16t squared times 26, or plus 26 times the sine of 45, that's radical 2/2, t plus 2. And so y equals negative 16t squared plus, let's cancel this, 13 radical 2t plus 2. Okay, so now I have two equations in terms of t, y, and x. Now, what I'd like to do is get this in terms of just x and y. Okay, I want to eliminate that variable t there. Okay, so how can I do that? Well, let's solve for t. So if I divide both sides by 13 radical 2, I get t is equal to x over 13 radical 2. Okay, now what I can do is I can sub this guy in here. Just kind of eliminate the parameter. So we get y equals, okay, now if you're taking notes, you might want to do this on the back side of the page. Okay, if there's room. Okay, there's not enough room. I didn't leave enough room in the notes to write all this out. Okay, so y is equal to negative 16 times x over 13 radical 2 squared plus 13 radical 2 times x over 13 radical 2. That's nice. Plus 2. Those 13 radical 2s are going to cancel out. Okay, what's 13 radical 2 squared? Well, that's going to be 13 squared times radical 2 squared, which is going to be 169 times 2. So y equals negative 16. This is going to be x squared over 13 squared times radical 2 squared plus x plus 2. Okay. So y equals negative 16x squared. Oops. I want to put this over. Negative 16 over, that's 169 times 2. Okay. X squared plus x plus 2. Okay, that's 16 and that 2 are going to cancel. Okay, and so we get y equals negative 8 over 169 x squared plus x plus 2. Okay, so now I have the equation of a general parabola. Okay. Okay, so what is this parabola going to look like? Well, when x is 0, I'm going to get 2. So that's where I start. I'm going to say when t is 0, y is 2. And that makes sense because that was my initial height. So if I look here, I kick the ball from an initial height, and then I get a parabola. I get an upside down parabola, and eventually it's going to hit the ground again. Okay. So what I'd like to know is well, how far did the ball travel? Basically, for this point xy, what value of x am I going to have there? Well, what's the value of y when the ball hits the ground after it gets kicked? Well, yeah, the value of y is 0. So this point here is really x comma 0. So what can I do? Well, I can take this equation, I can plug in 0 and then solve. Okay. So it's quite a lot of work. So 0 is equal to negative 8 over 169 x squared plus x plus 2. Now you can do this on a calculator. Okay, you could graph this and find out where the zeros are. If you wanted to, you'd have a 0 that would be negative. Okay, as well, but we don't count the negative because we're not going backwards in time. Okay, so we only want the positive root here. Okay, positive x value. If I did the quadratic formula, again, it'd be kind of messy. It's doable. You know, you would just do -1 plus or minus the square root of 1 -1 or +1 squared minus 4 times a, which is -8 over 169, times c, minus 4ac, all over 2a, 2 times -8 over 169. You plug all that into a calculator, okay, and out pops an x value of, if you use the addition one first, that'll give you a positive value. I believe, is that right? I think it's a subtraction because we're dividing by a negative on the bottom. So if you use the subtraction one, that gives you a positive value of 22.96 5. Okay, and so you're going to actually end up kicking the ball 22.965, or about 23 feet. Okay, so that's how far the ball travels. So we can plug that back up here. How far does the ball travel? 23 feet. Okay. And again, plug this into your calculator and you'll get one value that's negative and one value that's positive, and it'll come out to about 23 feet. Okay, I'm not going to do it here for the interest of time. You can verify that on your own. Okay, how high was the ball kicked? Well, what we really need to do here is we need to find out what is the x value at the top of the flight of the ball. And the top of the flight of the ball there is the vertex. Okay, so the vertex Well, where does the vertex occur? Well, the vertex occurs at negative b over 2a, comma, f of negative b over 2a, whatever that negative b over 2a is. We plug that back into the function. And that f of negative b over 2a, that's going to give me my height value. Okay. So negative b over 2a, okay, negative b over, this is freaking out, over 2a. Let me refresh real quick. There we go. Okay, negative b over 2a is equal to negative 1 over negative 8, or sorry, 2 times negative 8 over 169. Okay, so this ends up being, the negatives cancel out. And then I'm going to flip that fraction that I'm dividing by, I'm going to flip that over. So the 169 actually goes on top. And then I get 16 on bottom. I get 169 on bottom. So that's the value for x that I'm going to end up plugging into my function. Okay, so y is equal to, okay, again, my function is over here. I'll highlight it. Okay, there's my function. So y is equal to negative 8 over 169 times 169 over 16 squared plus x, which is 169 over 16 plus 2. Okay, and then when you calculate that out, maybe I'll do it just on the calculator real quick. That one's not as bad of a calculation. But it should come out to about 7.28 if I calculated it right before. So that's going to be, okay, negative 8 over 169 times 169 over 16 squared, oops, squared, okay, plus 169 over 16 plus 2, okay? And yeah, we get about 7.28 or about 7.3 feet. Okay. Let's go back. Oops. Go back here. Okay, so this is equal to 7.3, about 7.3 feet. Okay, so that's how high it was kicked. We can go back here and put in 7.38 feet. Okay, so now we need to know, well, what was the flight time of the ball? Okay, what was the total time that it took? Okay, and we could actually get that pretty easily from the parametric equations. Okay, we do have this equation here that we could solve. We know what x is when the ball hits the ground. It's the x, we already calculated that to be about 23 feet. And we know what v naught cosine theta is, so we could just solve for t. Okay, again, that's this equation here. Okay, I'll highlight that one, maybe in a different color. Okay, it's right here. Okay, so t is equal to x over 13 radical 2. Okay, so let's just say, well, x when it hit the ground was 23 feet from the origin, from where it originated. So we can say, well, t is gonna, the time that it takes to get there is gonna be 23 feet over 13 radical 2. Again, that's an easy calculation. 23 divided by parentheses 13 times square root of 2. Okay, is about 1.25 seconds, so about 1 1/4 seconds. Okay, so about 1.25 seconds. Okay. If you did calculate this out, you would get 20 before and this, this big quadratic. If you calculated this out, okay, you would get a slightly more accurate number if you use the number that was in your calculator, but for all intents and purposes, this is fine. Okay, so 1.25 seconds of flight time for the soccer ball. And I hope the guy made the score. Okay, I mean, if he was aiming for the goalie or something, I hope that he kicked it 23 feet and it went up 7.38 feet over his opponent's head and right into the goal. Okay. Okay, and that is it for, for the course. Hey, congratulations and good luck on your 8.3, or sorry, chapter 8 exam. Okay, and I will see you later. Bye.